Hi and welcome. This is Tom with Teach Me Tom. I teach programming and I let you know how you can get started in your programming career. This is what I do. I've been a software engineer for more than 25 years. And today the goal for the stream is to talk about how to structure your learning path. You want to learn a programming language. If you want to learn programming, there's a couple of high-level concepts that you have to grasp and that you have to learn. And the goal for me today is to make a list of things that I'm gonna cover in the next couple of days and weeks. And if you want to do that with me, you can go to teachmetom.com/code, where you can register and download free material for you to get started. Or if you don't, then just take this list to tick off what you need to do. What kind of things you need to learn. And with that, let's get going. I'm gonna switch to my browser here and we're gonna make this list together. Just quickly, how am I going to create this list? Well, first of all, I've been doing this for a couple of decades. I've been teaching programming. I've been a professional programmer myself. I published all kinds of software projects, my own apps with a couple of million downloads. So I kind of know what I'm doing. But on the other hand, there's a couple of resources that are freely available everywhere, of course, on the web. And I've got a couple of books here with me. For example, here, this book, Thinking in Java by Bruce Eckel. That was kind of one of my first books that I bought. It's pretty extensive. That's my copy is from 1998. So you know I'm that old. I've got a couple of other things here as well. There's some seminar manuals that I've been teaching with. There's this book called Data Structures and Problem Solving Using Java, where I will have a look at. And there's the official Java tutorial by Oracle. Oracle, the company who bought Sun, the company who originally invented Java. And the question is, why am I going to teach Java? Well, I think that's the most universal language that you can learn today. And it's very easy to get into. And the concepts that you learn there and the syntax that you learn there, you can apply to all kinds of modern programming languages, right? If you want to go the Microsoft route, you can adapt the things that you've been learning with Java to C#. That's a programming language that Microsoft is using in most of their stuff. You can learn JavaScript if you're more interested in the web development route, and the syntax there is pretty similar to Java. There's a couple of different things to learn, of course, but the basics of how to structure a program, what kind of things you need to understand, like variables or control structures. And don't worry if you don't know what I'm talking about right now. But the high-level concepts are the same. And this is what I want to make a list of right now. What are the high-level concepts that you need to know when you learn programming? And then you can apply this either with me, and we're going to learn Java together, or you can go wherever and have a list, sort of like a shopping list of things to tick off that you need to take care of. Okay? So let's switch to my document here, how to learn programming high-level concepts. And I think we're gonna have some sort of introduction where I'm going to talk about what's a computer. That's kind of basic, I know, but still, like I want to talk about the concept of having input coming into a programming. Then we're going to process that input, and then we're going to output that together. In some way or shape or form, that's always what's going on in a computer program, right? You're going to take some input either from the user by tapping the touch screen on your smartphone or by entering something on the keyboard. Then it do some processing in your program, whatever it is. Maybe you calculate some things, or you're gonna send some stuff over the network, and then you're gonna output some things, show it on a screen or send it to a printer. Most usually you show it on the screen, right? But even if you don't have a screen, if you're writing a program that sort of communicates with other programs, you've always got this input, output, and processing step in between. So we're going to talk about that. And yeah, that's let's just keep this with the introduction right now and skip to the next part, where we're going to talk about variables. Variables are the things, the sort of like little compartments in your computer where you store data, right? And we're going to talk about data types there. So we've got numerical data types where you can store numbers, and you've got texts or character data types. And then we have some operators, some stuff that we can do to these variables. We can sort of add together numerical data types, or we can have operations on these text variables that we're going to talk about. And I'm gonna jump around because I'm using a couple of different sources, like I said, like this book here, or the other kinds of manuals that I was talking about. And I'm gonna see how they are structuring their stuff, and I'm see what I want to do. The thing that I'm not that happy with in the way that I read the books and see the materials for seminars. Let me switch over to the big camera for a second. The way I'm not happy with stuff like this or stuff like this is they start, from my point of view, they start way too advanced. They're talking about objects and classes on the first couple of pages, right? And I try to picture myself 25 years ago when I was starting to learn programming or starting to learn Java professionally. And I had a very difficult time with these kinds of books. First of all, there weren't that many books available yet, and there was no internet with Java tutorials. But they all started too quickly and too fast. And what I want to get across when I'm teaching these kind of things is I really want to start with the basics, and I really want to assume no prior knowledge, right? So don't get worried if you read operators now and you're not really sure what this means. I'm going to explain it step by step. And this is where I will probably jump around, and I'm going to collect the topics that I want to talk about, but then I'm going to arrange them together in a way that I think makes the most sense, right? So the next thing, if we have variables, if we can store data, then we can react on that data. We can sort of have different things appearing or being done in the project or in the program related to what the data is that's being stored. For example, if the user inputs something, if we accept a number and the number is supposed to be the age of the user, we can do something. We can execute one part of the program where if the user entered an age that's 18 or above, and we can do something else if the user enters like 17 or below. So we can, this is called control flow statements. It means we can control the flow in the program. We can define what parts of the program are being executed depending on some data that's stored in variables. And there's a couple of things. There's the if then or if then else statement. So sort of programming is not that hard if you sort of come from know where you're coming from, know the context. When we talk about control flow statements, that sounds kind of well, what's that supposed to mean? But if I'm telling you before that we can do different things depending on the data that was stored in the variables, and these one of these control flow statements is called if then else, then I think even if you've never written a single line of code before, you can get some idea of what that means, right? So for example, coming back to my previous example, if the age is 18 or above, then we can do some things, execute some block of code. Else, if it's not 18 or above, then we can do something else. And we can sort of have the program react on the data that we have inputted there. So let's switch back to the browser here. If then else, we've got the switch statement. That's sort of like many if then else statements, one after another. And then we have loops. And loops are important because they let us execute parts of our code multiple times. So why would we want to do that? Well, the idea of programming is basically splitting things into different parts, into different modules, into different blocks of code, like Lego blocks that we can use again and again. And each block of code is related to some specific actions, has some specific task that it should do and that it should execute. And with a loop, we can sort of have a block of code and then do this block of code a couple of times. That's called a loop, and there's a different types of loops. There's the for loop, and there's the do while loop, and the while loop. Well, we're probably gonna switch that around, and we're gonna talk about the while loop first. So that's loops are also some kind of control flow statements. And I think that's about it for control flow statements. And let me see whether we need to do anything else in terms of like the basics of programming. I'm looking at my script here. Yeah, I think we're gonna talk about assignments as well. Yeah, let's do that. I've sort of missed that here before. Let's talk about statements in the introduction. That means we've got to tell the computer what to do step by step, and these steps are called the statements. And we've got the operators here and the assignments, and then we can also have the comparison operators. We can compare, if we store a number in one of these numerical data types of the variables, then we can compare it. We can, for example, say, and we need these comparisons in the if-then here, in the control flow statements. We say, if the number is greater than 18, if the age is greater or equal than 18, then we're going to do some things, else we can do something other. And for this, we need these comparisons. And then we're going to talk about classes and objects. And this is kind of the cornerstone of modern programming. We talk about object-oriented programming. And what that means is basically that you have certain parts of your program, certain things that you can group together and say, well, that's an object, like in a real world. You've got objects. You've got things that have certain properties, like my smartphone here has some kind of mass and it has some dimensions, a height and a width. So this is kind of the introduction into classes and into object-oriented programming, OOP for short. And we're gonna talk about properties. We're going to talk about methods. So property is something that an object has, and a method is something that an object can do, right? So for example, if a calculator has a number of buttons and a display, and it has a weight and a mass, these are all kinds of properties. But the methods are the actions that I can do with this calculator. For example, I can punch in some numbers, right? And then I can see what I punched in the display of the calculator, or I can add numbers together. Of course, that's what a calculator is for, right? To do some calculations on the numbers that I entered in. So remember that what I said about the input, output, and process. That's kind of the example with the calculator, right? My input is the numbers that I'm punching in. The processing is the calculations that I'm kicking off, like addition or subtraction or whatever it is. And the output is then the display of the results of my calculation that I was doing on the calculator. Input, process, and output. And this is also what object-oriented programming is about. So I would say that's about it for the introduction of the object-oriented programming. I need to talk about how we can create objects. There's something special called the constructor. That's a certain kind of method that sort of constructs a new object. And I can talk about methods. Then the methods are the actions that I can call on an object, and I talk about return types. That's something that the method gives back. So if I write a calculator object, if I use a calculator object and I have a method called add that can add two numbers, the return type would be another numerical type, like an integer type, or yeah, some kind of number. We're going to talk about the different number types that I should actually add here as well. We're going to talk about integers, and we're going to talk about float and doubles. What that means is integers are sort of like the whole numbers, like 2 or 5 or -4, and doubles or floating point numbers are numbers that have a decimal dot here, like this. And we have to talk about this. And then I forgot the Boolean type, which is basically just true or false. Right? We can store just true or false, 0 or 1, 1 or 0. I think that's about it. Yeah. Okay, so getting back to the return types here, I'm gonna need to scroll this up a little bit. We can return something from the method, and we can also give some input parameters to the method. We can tell the add method of our calculator to add two numbers together, but that means we have to give these two numbers to the method. So this is what we're going to do with the input parameters here for the methods. And I think that's about it for the method so far. Yeah, let's talk about also about error handling. And this is a topic where it might get a little bit language specific. So we're going to talk about error handling in relation to Java, but this might be something different if you're using another language like JavaScript or C# or even Python. So I'll write here Java specific ? And in Java, this is called exceptions, the error handling. So the reason why I was thinking about this the other day, the reason why I think it's pretty fitting that they named it exceptions, because if you execute your program, then you expect it to behave in a normal way, and that's sort of the normal use case, the default case that you expect. But if there's some error appearing, if something doesn't work, maybe the network isn't there, or the user entered something specific that's actually prohibiting the program to execute further, then this is an exception. This is an exceptional case. This is an error case that we need to handle differently than the normal case of the program, right? So these are exceptions. Then we're gonna talk about, let's jump back to classes and objects. First, I forgot something here. We're gonna talk about interfaces. These are kind of like objects without an implementation, all classes without an implementation, and we haven't really talked about the difference between classes and objects here. So we're gonna add this to the introduction here. Differences, classes and objects. And just for you as a quick primer or what this means is actually the class is kind of the blueprint for an object. Think about like you've got a blueprint of an object that you want to build, right? For example, if you go to IKEA and you buy some kind of furniture, right? Maybe I don't know, a desk. You've got some instructional manual there that tells you how to construct that desk, right? How to put together the pieces, where the screws need to go in, etc. So you can think of the instruction manual as sort of the class, the blueprint, how you're gonna construct a new object of that type desk. But this is something different. The manual is something different, and the instructions are different than the actual object itself, the actual desk itself, right? So the blueprint is the class that tells you how to create a new object, how to wire up a new desk, and you can use the same manual to create, to build up multiple desks, right? So you can use one blueprint, one class to create, if you buy them, as many desks as you want. You can do this all with the same manual. You don't need more manuals, right? But you need more objects, and the objects are the actual instances of the thing that the blueprint was providing, or the blueprint was explaining or telling you how to construct. Okay, so class is the blueprint, the object is the actual thing that you are constructing there. And we need to talk about this difference here. And you see I'm going back and forth there and adding things to these high-level concepts here, because I'm doing this together with you, and I'm trying to explain the overall idea. And I don't have any. Of course, I have manuals here, but I'm not happy just copying them one by one. So this is why I'm doing this together with you. This is why I'm going back and forth with you here. Okay, so let's see. What else do we need? Well, we're gonna talk about getting back to the object orientation here. And let me tell you, I'm gonna shift this to the next page here. So we said we're gonna talk about object-oriented programming, classes and objects, how we're gonna create objects, what these objects do, the methods. Talk about interfaces, but we don't need to talk about that. We need to talk about inheritance. What this means is that I can describe an object or a class, like the blueprint that I'm having, and the classes can inherit from each other. I can say I can define a certain kind of class of desks, for example. For a desk always has 4 legs, and but there's specific variations of desks, right? I can have a desk that moves up and down, that I can change the height of the table, actually, of the desk table. What else could I do with a desk? Well, it could have different kinds of material. It could be made of different kinds of material. Maybe a desk isn't actually the best example, because a desk can really do anything. Let's talk about a car, for example, right? A car, so the class of cars always have 4 tires, right? 4 wheels. But there's different kinds of cars. Obviously, there's an electric car. There's a what's a propulsion, or actually what's the other kind of engine? I don't know. I'm not a big car guy here. But the thing is that you define sort of a generic class car, and then you can inherit from that car. And you can have an electric car, and you can have a small car, a big car. So these are details, specific details that inherit from this generic class, a car here. And this is what we're going to talk about in this inheritance chapter here. And this is kind of like the cornerstone of understanding this object-oriented programming paradigm, which is so fundamental to all modern programming in the last 30 years, 40 years, something like that. So this is really something that you need to grasp, but it's also, I try to make it easy, and we're going to do lots of different examples so you can try out the thing. So the problem with making this list here is it's kind of dry right now, and if you really have no prior experience with programming, I would understand if you would think like, well, these all what's kind of what do all these strange words mean, right? And although I'm trying to explain what I mean, it's kind of abstract. So I'm really aiming to make this as logical or as practical as possible. But we need to talk about inheritance, and this is where I wrote this down here. Let's see what else we need. There's something that I forgot here with the variables, and that should go below the control flow statements actually. And we're gonna talk about arrays. So arrays are a special kind of variable. You can think of it like a collection, a group of data that's all sort of has the same meaning. For example, you could store a number of different age values. You've got a group of kids and you want to store, for each kid you want to store their age. So you could combine them together into an age array, which is basically, a collection, a group of primitive of these numerical data types, and then you can do something special with this array. You can loop. That's why I'm gonna do this after the loops here. You can go through each and every element of this age array, and you can add all the ages together, or you can then calculate the average of all ages in this age array. Okay, so we're gonna talk about these arrays, and this is important. Right. So we're gonna have a lot of different examples there with classes and objects. What else do we need? Let's see. Well, we're gonna talk about collections, and this is where it really gets Java specific, I guess, or at least in the way that I'm going to teach it, because that's. I mean, the same concepts are there in different languages, but the names are different. What do I mean by collections? Well, in programming, you always deal with data, and the data has more or less a kind of structure. So you've got different objects. For example, think of your smartphone again and think of the contact list. And each contact has a name, a first name, a last name, a telephone number, an email address, whatever it is. So this is kind of a data structure that's defined for this class, person, or contact list entry, or whatever you want to call it. And then you've got a list of these contact list entries, right? We've got a list of persons, and this list is handled in a specific way. And they could be stored alphabetically. You could have lists of objects where each object has to adhere to some kind of conditions, so that it might appear only once, which doesn't make sense. Well, actually, it makes sense in a contact list. But yeah, there's a different kinds of ways to group together objects of the same kind. So this is where we talk about collections, and we have lists that we're gonna talk about, and all kinds of. Well, let's keep it at lists. I don't want to bore you with the details there. So let's see what we have here. Introduction, variables, control flow statements, arrays, classes and objects, and collections. I think, let me check my thinking in Java here. This book, which is actually, you can download for free on the website. It's called Thinking in Java by Bruce Eckel. I'm going to link it in the description below. So let's see what he has there. We've got a controlling program flow statements, initialization and cleanup, reusing classes. Well, we could actually do that here. Sorry, you don't see this right now. There it is. Reusing classes. Polymorphism. I'm gonna write it here and I'm gonna explain it in the course, but yeah, it's not important to know for you right now. Basically, what it means is just to give you some idea. If you're defining objects or classes, actually that sort of depend on each other, you can use them very dynamically. You can use one class when the program expects something else. Yeah, it's all kind of funky and very cool, and promotes reuse of your code, which is basically what it's all about. You want to define. You want to find a structure for your program that allows you to reuse as much code as possible. There's one very important principle. It's called don't repeat yourself, DRY, which means that you shouldn't write a single line of code and duplicate it somewhere else. If you want to duplicate it, you should probably extract it and make it its own module, make it its own method, put it somewhere where it can be reused. But copy pasting in programming code is very problematic, because if something changes, you need to remember that you need to change it in multiple places in your program, and yeah, this makes it easier to introduce bugs and yeah, to not really heighten the quality of your programming. So let's see what Bruce else has here. We talked about arrays, we talked about collections a little bit. Well, if we talk about collections, we're going to need to talk about enumerators. That's kind of the way to iterate over things that are in the lists or in the collections there. But it's also not important to know the details right now. And I think that's where I want to keep the sort of initial overview. If I'm gonna cover everything there, this is already a lot and gives you a huge boost and a huge advantage over everybody else. And again, I'm trying to do this not in a language specific way. I'm gonna use a specific programming language, of course, because otherwise we can't do any examples with it. But yeah, you should be able to, at least that's my goal, you should be able to apply what you're learning there to whatever language that you're choosing. And besides, if you're learning programming language, if you're learning Java, then it's something that you can use pretty much everywhere, right? Java is a universal programming language. It's not the best programming language for anything, I would say. There's a couple of drawbacks, but just the fact that you can use it pretty much on any kind of computer. Let me show you something. Got here. Do you know what this is? This is a Raspberry Pi. I don't know if you can see this, but it's a very, very tiny computer. I mean, you see the size of my hands, and my hands are not big, I'll tell you. But you can run Java on this small computer here. That's a computer by itself. You've got USB connections here, you've got a network connection, you've got an HDMI connector. This is something that you can program with Java. Of course, you can program it with other programming languages, but Java can run there. You can have Java run on your smartphone, not on this one because it's an iPhone. And Apple does its own thing, but on Android phones. Android phones are the majority of the market share, right? I don't know, 80% or something of all smartphones in the world run Android, and you can program Java there. Java was used to program Minecraft, for example. The original version of Minecraft was programmed in Java. And besides, all kinds of major insurance and big corporations that are running stuff on their servers, on their big backend servers, are either running some version of Microsoft stuff, but usually they are running Java there, and not just for very specific things. You use something else. So Java is very universal, and it gives you, it's a cool programming language to learn and to get the concepts of object-oriented programming, and you can use it everywhere. You can apply what you're learning there to whatever you're interested in. If you're interested in programming your own stuff and connecting kinds of sensors, temperature sensors or humidity sensors, and then to output something, again, getting input in, processing it, and outputting something, You can do that with that if you want to program your smartphone. You can do it with that if you want to have a career in programming and get a job in a big corporation. Then having learning Java and knowing Java is a big advantage for you. Okay, so that's about it for today. I'm gonna finish off here with just a quick recap of what we did. We thought, we collected different sources of tutorials or of books. Actually, I haven't looked into this book, but I'm gonna do this the next time. Data structures and problem solving using Java. But I think we pretty much covered everything. If you want to have this list to download, this list of concepts to download, this is something that you can do get at teachmetom.com/code. If you're interested in learning together with me, then just subscribe there, teachmetom.com/code, and get everything for free. And let's learn together. Let's demystify programming and learning a programming language, a modern object-oriented programming language like Java. So with that, I say thank you for watching and hope to catch you soon on this stream or on a channel or wherever you're watching. Take care. Bye-bye.